All right, so we're going to do another example of summing an arithmetic sequence, but this time we're going to try to find a closed formula rather than a sum. So what this looks like is we have this sum that's given to us, 6 plus 10 plus 14 plus ... plus 4n minus 2. All right, so we know that this right here, this 4n minus 2, tells us kind of the general form of a term in our sequence. So we don't need to find that since we're already given it. And obviously this term is going to correspond to just n, right? So the first thing we want to do in this case is to find how many terms there are in the sequence. So we need to start with this 6 over here. And 6 is going to be equal to 4n minus 2 for some value of n, right? Because every single term in our sequence has that form of 4n minus 2. And we want to know for what value of n is that. So we would solve that for n, so divide by 4, and get n equals 2. So this corresponds to n equals 2. I'll let you check that 10 corresponds to n equals 3. 14 would be n equals 4, etc. So the terms in our sequence go from n equals 2, 3, 4, all the way up to n. So then the question is, how many of them are there? Well, since we're excluding 1, we're going to have n minus 1 of them. Oops. Okay, so just take a minute to make sure that you agree with that. For instance, if n was equal to, let's say, 15, if we go 2 through 15, that would be 14, right? Because we're excluding the 1. So we have n minus 1 terms in our sequence, and we know that we're going to need that to be able to calculate our sum. All right, so the first thing we're going to do the next thing, I guess, to start calculating the sum is we're going to write it down just like we did before. 4n minus 2, and then we're also going to write it down the same sum but backwards. So 4n minus 2. So this term right here that I want to write down is going to be if we plug in n minus 1. So I'm going to do this kind of over here as scratch work. That gives 4n minus 4 minus 2, which is 4n minus 6. So that tells us that the second to last term up there is 4n minus 6, and then plus ... Of course, you would have 10, and then 6. And maybe if you wanted to, we could even write the 4n minus 6 up here, so we can kind of see how they're adding. All right. So remember, we have the sum s written in 2 different ways, and then we're trying to add vertically. Okay, so adding this part, kind of the left-hand side vertically, gives us 2s, right? S plus s is 2s. And then here we have 6 plus 4n minus 2, or maybe we would normally write it like this. 4n minus 2 plus 6 is, of course, 4n plus 4. Okay, and I'm just going to put that in parentheses to make it look a little bit neater. They're not strictly necessary. But then when we add the next column, we get 4n minus 6 plus 10, which is, again, 4n plus 4. Okay, and then I'll let you check that when we keep doing that, we're going to end up with 4n plus 4 a bunch of times. All right, specifically how many times? Well, that's the same as the number of terms that we said were in our sequence, which is exactly n minus 1 in this case. All right, so we have 4n plus 4 multiplied by itself n minus 1 times. So we get 4n plus 4 times n minus 1 is equal to 2s. All right, well, since we called the sum, the original sum, s, we need to divide by 2 because we're asked to find s, not 2s. So that gives us the sum s is 4n plus 4 times n minus 1 over 2. And we could simplify that if we wanted to, although it's not strictly necessary to do that, because we could factor a 2 out of this first part here, the 4n minus 4, and that would give us what, 2n plus 2 times n minus 1 over 2, and then we cancel the 2's and are left with the sum. Whoops. Let me get a little bit more room here. There we go. We have 2n plus 2 times n minus 1. Whoops. And there's nothing on the bottom there because the 2 canceled. All right. So this is a closed form for our sum, and what that means is that basically no matter how many terms n we decided to use in our original sum, so say we decided to use n equals 100 terms, then we could easily find that sum by just plugging in the value n equals 100.